The most important function in NestLocal models is goal function. So in this ANT model, what exactly does the goal function want us to do? Every iteration, what does goal function perform? Let's have a look. So let's look at the first line of code. This line of code says if count turtles, meaning to count how many turtles exist in our world. So we count the number of turtles. If this number of turtles below the number of population is, see whether we can find out this one. Now we can't. But we already know that this population is a global variable defined by the slider population. We can define it by sliding the slider. So if the total number of turtles in the world is smaller, is below the population, now we will execute this code. By the name, we can see this function will help us create an ant. We can go there and have a look, see what exactly does create ant mean. It means just to create a single ant. It says create turtles, one, which means just one turtle, one ant. And we want the size of the turtle to be 2. And we want the turtle to have the property carrying food to be set to false. That's exactly what we do with create ant. Okay, let's go back. So as long as the number of turtles is below this level, we will continue to create more ants. So that's the first line of code. Once we created a turtle, we will ask the turtle to do something. First, we want it to move. Well, move is a user-defined function, so we will later look into what does move do. And then, after it moves, we will recolor itself. So what exactly do we do with the color? We will see later. So these are two user-defined functions. So once the turtle has finished its movements, we will dealing with pheromone. Here is a less local function called diffuse. Diffuse means it's dealing with chemicals. The chemicals, once it exists in the world, there will be wind, there will be other factors, so the chemical will diffuse. It will not stay in the same place all the time. It will diffuse to the surrounding areas. But how much does it diffuse into its environment? We can set the value. So we will use diffuse function, diffuse the chemical, which is the pheromone here. That is a value. And by how much? This is how much. So we can define a global variable called diffusion rates, which is right here. Diffusion rates, we can use slider to change its value. And divided by 100, which become a percentage or a ratio. So diffuse, the pheromone will diffuse by this amount into its labeling environment. And to note that here we use pheromone. Pheromone, as we know, it is just a property of the patches. So normally we will deal with pheromone under patch context, but here the pheromone, as we can see, is on its own. It's not under patches, it's just on its own. So I think that is because this function is very special. So we define this, we run this function, and it will apply this diffusion rate to every single patch towards their pheromone. Okay, so this is a very special thing we should remember. And then we are talking about patches now. So for every single patch, every time we run this model, we simulate, we iterate, every patch, its pheromone need to update itself, because every time we iterate, the pheromone will diffuse certain amounts of itself to the surrounding area. So in the same patch, the remaining pheromone will decrease. Therefore, we need to update itself. So what is remaining is pheromone multiply the amount of vaporation. Vaporation means how much will be evaporated, will be disappeared, and the remaining is what is left. Okay, so that is what is left in every patch. Right, and if there is less and less pheromone left, when the amount is below 0.05, then we will consider the pheromone is already gone. So we set the value back to 0. This is about patch, and particularly about its pheromone, how the pheromone change. So to record the diffuse pheromone, so the pheromone will be reduced in 2 ways. First, in one patch, it has pheromone. Every iteration, it will diffuse to the surrounding area, so the pheromone in the original patch will decrease. This is the first decrease. And the second decrease is through evaporation. So maybe here we diffuse 50%, so only 50% left. And then evaporation rates maybe evaporate 10%, so only so that will be less pheromone left. So 2 steps to decrease the pheromone. So after the patch and the pheromone has been dealt, we need to repaint the patches. And we repaint the patches according to the amount of pheromone. This function we already learned in previous videos. And then we can deal with some other issues. For example, if we want to count how much pheromone, we want to know at every iteration which patch has the maximum value of pheromone, and we want to know the exact value of that maximum pheromone. We can use this line of code. We ask all the patches for their pheromone, and we find the maximum value and give this maximum value to the global variable called the max pheromone. And then we tick to count the number of iterations. And now we need to consider when to stop the iterations. There are 2 ways to stop it. One way is very easy. First, we create a switch called the stop by tick switch, which is right here. Stop by ticks switch. Set it on, and then we can set a particular tick to stop. So if we put it on and we say the user ticks to be 1540, so when these 2 conditions are met, the whole iteration will stop. That's one way to stop it. Another way to stop it is, say, we only want to stop the iteration when there's no food left in the world. So all the patches sum up the food and become 0, so food is gone. All the patches sum up the pheromone is gone. And also the stop switch is on, it's true, it's on. And when all this happens, okay, let's remember the ticks at the moment. For example, 10,000 ticks. We record this ticks number into finish time. And we, at this moment, will set the stopwatch to be false, because we don't want the next iteration to do the same thing. So we set back to false, and then we say 100 ticks later, ticks greater than finish time plus 100, which means continuing on, and 100 ticks later, we stop. the whole iteration, will stop the whole model. So there's two ways to stop the model. This is what the Go procedure has been running every time we iterate the model.